Hello and very warm welcome to everyone joining us. I'm Gayatri Mavre and I will be your host for this engaging evening today. We are gathered here today for an enlightening session titled From Campus Code to Cloud Deployment, Bridging the Academia Industry Divide with GeoAI, organized by Srishti Drushti Geospatial Foundation and technically supported by AIGR Training Institute. In an era where data is the new oil, geospatial AI is the engine driving sustainable solutions. Today, we aim to explore the synergy between classroom learning and real-world deployment. This event is a collaborative effort by two pioneering organizations, SDG Foundation and AIGR Training Institute. Srishti Drushti Geospatial Foundation is a Government of India registered foundation, Section 8 company, dedicated to mapping for a sustainable future. We are at the forefront of utilizing geospatial tools for environmental and social impact. SDG Foundation is flourishing under the guidance of President Dr. Brotati Vishwas, Professor, Mizoram University, and General Secretary Dr. JayantaDas, Professor, Assistant Professor, Rampurhat College, along with excellent core team, including me. The SDG Foundation is dedicated to creating a sustainable future through the power of geospatial vision. It strives to demonstrate geospatial knowledge and empower individuals and communities with mapping tools and spatial analysis skills. The SDG Foundation is now offering internship opportunities to the geospatial enthusiasts. You might have come across the flyer related to our internship opportunity openings. For more details on our ongoing initiatives, workshops, and how you can get involved with us, I encourage you to visit our website sdgfoundation.org.in. Details I will share in chat box after some time. The foundation is committed to fostering a vibrant community of geo enthusiasts and professionals. And events like today's webinar are a core part of their mission to promote the transformative potential of GIS technology for a better world. And you all must be familiar with our personal geospatial training provider, that is AIGR. So those joining us for first time, I must introduce them to the AIGR. Advances in geographical research is today's co-organizer of this event, and it is a ISO certified organization committed to the high quality research and professional training, helping bridge the gap between complex geographical theories and practical applications. AIGR platform is providing more than 20 basic to advanced geospatial courses at very minimal fees and helping us to learn from experts in the field. New courses at AIGR includes basic and advanced Python for geospatial analysis, flood analysis, drought analysis, LULC classification with machine learning, and topics like MCDM techniques, and many more. So SDG Foundation is thankful to AIGR for providing us with today's esteemed guest speakers, Dr. Arnav Ghosh sir and Mr. Ulhash Ghosh sir. Also, we are thankful to them for technically supporting this event. Moving ahead, today's webinar focuses on GeoAI, the powerful intersection of artificial intelligence and geography. We will be diving into fascinating topics like deployable geospatial AI, IoT, early warning systems, and spatial RAG engines. This session is specifically designed to show students and professionals how to take code developed on the campus and deploy it effectively in the cloud for industry scale impact. To set the stage, I would like to now invite our first resource person, Dr. JayantaDas. Dr. Das is an assistant professor in the Department of Geography at Rampurhat College, West Bengal. He is Secretary General at SDG Foundation. He has published more than 20 books and more than 100 papers dedicated to geospatial domain. He is actively engaged in training new generation to advance geospatial skills with his genuinely engaging style. With his deep academic roots, he will be explaining us about what GeoAI truly is and where the future of geospatial technology is headed. In a world of big data, how we can find meaning in locations. So, Dr. Das, we are eager to hear from you.
So, am I
Let
audible?
me share my screen.
My voice is clear now?
It's
No,
not
no,
clear,
sir.
really.
Still some glitches there.
It's cracking.
Sorry for the inconvenience. Good evening, everyone. I am Dr. JayantaDas, Assistant Professor of Geography, and it is a pleasure to be part of this important session on from campus code to cloud deployment. So it will breeze the academic and industry, and obviously with the help of GI. So before I begin, I would like to thank you, the organizer, for creating a platform where we can openly discuss one of the most critical challenges faced by the students, researchers today. And I want to start with a very honest observation. Actually, I regularly get call from many researchers, because in India, especially in West Bengal, every year thousands of students complete masters in geography. Many go on to do MPhil and PhD in earth sciences, geography, environmental science, geology. They invest years of hard work, deep research. They have strong theoretical knowledge. But after completing all of this, many of them still struggling with a simple question: what is my next question? And I get this call. They ask me, what should I do now after completing the PhD? They don't know after completing the PhD what they should do. Because in most cases, our academic system train us with only one direction: to enter academy, to, to become a lecturer or professor. And there is nothing wrong with that. But problem is, this is not only the pathway anymore. We have only one options now, but we don't have plan B, plan C, plan D. We have plan A. We want to go to academy, want to become a professor. But we all know this number of vacancy and number of PhD holder are mismatched. So what should we do? Let us clearly understand this issue. I found that there is a significant gap between academia and industry. In academia, we just focus on theoretical framework. We use static GIS mapping. We have published lots of research publication. But in industry, the expectations are completely different. They expect real-time processing. They expect automation of workflow. They need AI-driven decision making. And we can also use cloud-based deployment of workflow in industry. So what happened? Even highly qualified student, even a PhD holder, find difficult to enter the industry. Why? Not because they lack of intelligence. They know these systems. They have a strong theoretical background, but because they lack applied practical and deployment skill. They know how to build a model, but they don't know how to execute it in the real scenario. And this creates a silent crisis. That's why many students feels confused. They start, they're limited to very few career options. And they may have a strong thesis, good publications, high number of publications, a deep subject knowledge, but industry asking something different. They ask, can you solve real world problems? Can you build system, not just report? This is the shape we must recognize. If you want to entry in industry, we need to shape. We need to just change our mindset, nothing else. So question is today, how many, is not that how many degrees do I have? The real question is, what skill do I have that are relevant today? I always tell my students, try to follow the research paper who is published this year, not the 2025 or 2024. This is the backdated. Because your research paper will be executed, if it is published or if it is executed, then it will be executed after 2 years. Then you have to think for the futures, not for the past. You have to think for the futures. Because the world is moving toward data-driven decisions. World moving toward the automation system. World's moving toward artificial intelligence. And we have seen the last 5 years journey, this transformation journey. And geography is no longer isolated from this transformation. Obviously, we need to change. There is a paradigm shift from the static map to the automation system. And because of the artificial intelligence. Now, this brings us to very important concepts in geography, because we know the geospatial data. We know we have a concept of geospatial phenomena. And if we combine this geospatial knowledge with the artificial intelligence, then we can call it as a GeoAI. So GeoAI is a geospatial artificial intelligence. GeoAI represents a new direction in geography, where we can combine geographic knowledge, obviously. This is the traditional or fundamental knowledge, spatial data, artificial intelligence. To create an intelligent system, we need to create an intelligent system which will combine 3 things: geographic knowledge, spatial data, and artificial intelligence. Let me explain this in simple terms. GeoAI is integration of what? I'm working in this field in GIS remote sensing since last 10 years or 10 to 15 years. Now, GIS integration of GIS and remote sensing. And last 5 years, people published lots of papers using machine learning and deep learning. And if you prepare one paper and submit anywhere in any journal, your paper will be rejected if you use machine learning and deep learning technique. Because these are now backdated. Because we need to combine all of this: GIS and remote sensing, machine learning and deep learning, spatial analysis, and big data. If you combine all of this, then it will allow us to analyze the large-scale spatial data set. It can automatically detect the pattern. It can predict the future geographic event. Okay, for example, suppose predicting flood before they happen. Last year we have seen one big flood in North Bengal, but we didn't have any information prior to this event. So we can monitor the flood event using GeoAI. We can predict it. We can monitor crop health using satellite data and advanced GeoAI. We can identify the urban expansion pattern, where future urban expand and which directions. So instead of just analyze the map, we start building the intelligence system. Now, most important question for me, how does GeoAI transform your career? Because I am very much worried about the today's career opportunity from geography. Lots of them, everywhere they will know what happened after completing the PhD in geography. Nothing else. So that's why now our subject in more depressions. But I must say, GeoAI gives you a dual advantage. One thing we should focus on for our academic growth, and another thing it will give us to get a chance to entry in the industry. In academy, you can work on advanced research topic, and you can publish in high impact factor journal using real world data set or applying the modern methodologies. But at the same time, you become eligible for roles like GeoAI analyst, or today's speaker, Mr. Ullas Ghosh, as a GeoAI analyst in industry person. Like remote sensing AI specialist. I know many people, those are from geography background now, working in industry as a remote sensing AI specialist. Geospatial data scientist, GIS developer, because after knowing this GeoAI, you can build a model, you can automate the workflow, you can deploy the solution. So industry looking for these types of skills. There's a big gap. Many NGOs, many industry, they request me, sir, send me a very good person, skilled person. Those know the automation systems. But there's a gap. So I must say, GeoAI transform you from a degree holder into a problem solver, who is industry looking for. So we need to change our mindset, I must say. Instead of thinking what degree should I do next, we should ask what skill should I build now? Because the future belongs to those who can combine geography with AI, who can work with the real data, who can build the real solution. And this kind of transformation really required proper guidance, obviously. Without help, you cannot do, because we are from non-coding background. So we need proper guidance, we need the structured learning pattern, and also hands-on experience. Because GeoAI is not something you can learn only from theory. It needs the practice, it needs projects, it needs real-world applications. And Gayatri Madam already told you, we have announced one internship program, hands-on or field-based internship program we are offering now. So we'll teach how we can work with the real-world problem. This type of initiative, like this training program, are designed to bridge exactly the gap between the learning and doing. We know many things, but we cannot do. That's the gap between learning and doing. So with this understanding, we will now move into more detailed discussion. We have with us Mr. Ullas Ghosh, industry person. He will connect this idea with industry practices and real-world deployment. Also, we have Dr. Arnav Ghosh. He will take you deeper into academic and technical aspect of GeoAI. And I'm confident that this session will help you rethink your career direction. Thank you. Thank you again. Thank you very much for joining with us. Over to Gayatri Madam.
Thank you so much, sir. So as truly said, Dr. Das sir said that with just traditional education system and degrees and certificates, we can see lots of struggle. But at the same time, there is immense opportunities available with the futuristic skills like GeoAI. So for that only we have organized this webinar. Moving ahead from what to why of GeoAI, now I invite Mr. Ullas Ghosh sir, a TTT certified trainer at Wipro and a Google Map trainer, to guide us. Before that, I will introduce you to our today's speaker, Mr. Ullas Ghosh sir. Mr. Ullas Ghosh is a seasoned GeoAI engineer and geospatial data scientist from Kolkata, with over a decade of experience in GIS operations, remote sensing, and AI-driven geospatial solutions. He has successfully led large teams and delivered complex projects for global clients such as Google Maps, Here Maps Southern California Edition, and Scottish and Southern Electricity Networks. Ulhash specializes in bridging traditional GIS with modern machine learning and deep learning techniques, leveraging Python, computer vision, and cloud deployment tools to build scalable, automated mapping and monitoring pipelines. His expertise spans geospatial data science, process automation, and industry-focused AI applications, making him a recognized leader in advancing deployable GeoAI solutions for academic and industry alike. We are fortunate enough to have Mr. Ulhash Ghosh sir with us here today. Today, he will discuss the industry applications of GeoAI and the massive opportunities currently available for skilled professionals. Mr. Ghosh, we look forward to your address.
Good evening, everyone. Can you hear me?
Yes, sir.
Yeah, hi. Thank you, Gayatri. Good evening, everyone. And thank you to Dr.JayantaDas. He has given me this opportunity. And thank you to my co-mates, Dr. Arnab, sir. So I hope till now everyone is not enjoying at all, or you might have to pay a lot of attentions to this. But in industry, uh, I will give a small intro of myself. I'm here for last 13 years in this GIS domain, 13 to 14 years probably. And I'm enjoying this in industry, and further I will enjoy more because this GeoAI came in, right? And this lecture till now, this 1 hour, it might be boring, but next few minutes or till my sessions are there, I will make sure it is not boring at all. And we are taking back something in home, right? So let's do it, guys. Yes, let me share my screen quickly. Can you guys see my screen?
Yes, sir.
Okay, so let's bring back the energy. Geospatial artificial intelligence, this word, right? Geo AI, or the artificial intelligence for nowadays, like last 2 to 3 years, probably. There is a boom. Wherever we go, we see this word or we hear this word. And guys, before going forward, there might be some disturbances from my side because I live beside a child's park, right? They are playing and it's 7:30 till now. No one is there to stop them. So it's up to the parents. Okay, so moving forward, guys, this artificial intelligence, we are hearing from whenever we woke up in morning, starting till we go to sleep. Nowadays, everywhere is this word, and it is changing our life drastically. At the end of the day, all the scientists, all the scholars, all the researchers, all the industry people, everyone is trying to make our life comfortable and easy. That is our mantra for intelligence, artificial intelligence, or robotics. After this, robotics will come on. So moving forward, I have worked in a lot of domains in this 13 year, agriculture, utilities. I have led a lot, like 60, 70 FTs. Uh, but what I feel like when I was contacted by Dr. Jayanta sir or Dr. Arnav sir, so when I spoke with them, I understood the gap. Currently, we have everything, right? The doctors, the scientists in this call, I have noticed few scientists, few doctors are there in this call. They know everything theoretically. Very few of you guys are applying it in industry sense. So we know till now, right? If we go through the current structures of current IITs of the Indian system, or even if you go abroad, the systems, the educational systems will teach you till the academics, even if they will teach you till machine learning, deep learning, or creating models. Well, but no one will help you to understand how these models will be deployed. If you cook biryani and tomorrow you want to sell it off, first of all, you need to pack that biryani. And then you need to call the Zomato, you need to have a bonding with Zomato. Maybe it can be financial bonding or any type of bonding. Then the Zomato person will come, you have to give the biryani, and then it will be sold out and distributed. In the same way, whatever models we create in GIS or geospatial artificial intelligence, whatever models we create, it is just a project till it is in your laptop. It is just a project. To make this project into a product, that is our main target. Because at the end of the day, we will be selling products to our client or customers. So we have to change our mindsets, right? We know everything, but we are not been able to express it, right? Or we are not been able to apply it practically. So let's move forward. So that is the base of this lecture or this seminar. I very rarely I like take a part of this and this type of seminars. I very rarely take part because I don't get time. And look at your screen, guys. In right hand side of your screen, you can see a image of Earth, right? So we might know that there is a Greek philosopher who has said Eratosthenes, right? So Eratosthenes said that or invented this Earth is a spherical thing. So that is a fact, right? He proved it through arithmetic calculations. Now that fact is what? It's a data, right? It's a meaningful. Whenever any fact is meaningful, it becomes a data. Or even if it is not meaningful, also it is a data, right? Whatever we know about this Earth, it's a fact and it is a data. So the data or the bundle of data, when it is going through a proper, it is like it is having some meaning and it is useful for us and it is transformed or it is going through a lot of phases. So it will become a information, right? A bundle of data is called information. Now what happens when there is an input of these informations and there is a processing and then there is output, there might be problems, bottlenecks, at the end of the day, delivery, right? So there is output. So at that time, we call it as a complete system, right? So the information systems about Earth or geography, whatever we read in academics, is GIS. Now comes the bigger part. Now, for last few decades, we have been hearing the word named as data science, data scientist. What these guys do, right? So they play with data. They eat data, sleep data, drink data, right? So they play with data. And what happens when this data is turned into a pattern? We are telling the machines to go through and we are feeding the machines to learn the pattern. At that time, what happens? It turns into a machine learning. We are making the machine learn the data patterns for analysis part. Now coming to a bigger picture, when this machine learning part, they are not been able to solve certain issues, if we go to deep learning part, completely automated, the feature engineering is taken out of it, right? Then comes the ultimate AI. AI till deep learning, it's not AI, guys. AI is something which has its own brain. It can interpret something. It can do predictions. It can do forecasting. Then only it is an AI, right? So that's what, because academic, while reading theories, doing research papers, journals, publishing things, there is a trend. People think completely monotonous. We need to change our thinking. We need to understand what is an intelligence, right? Moving forward, guys, what we will cover today. Today, I will be going through like what will be covered in this whole course, right? In this whole course, we will be trying to bridge the gap between GIS professionals, GIS scholars, GIS researchers, GIS students, and we will try to make them, we will try to make sure that they are getting an opportunity in real world applicable solutions where it will be, of course, through industry, right? So we will be teaching foundations in these courses. And of course, we will be going with the methodologies. We will be going with the domain. Now, tell me this thing, guys. Domain is, of course, great. We are always specific towards a domain. I want to do my research on agriculture crop monitoring. I want to do my research on retail business. So domain is of course good. Land over, land use, land cover, flood, disaster management, everything is fine. But domain, if you know GeoAI, you know the basics of it till here only, till the methodologies, the foundation, the methodologies. If you know the explainable AI and the basics of it, you can apply it to any domain. Domain won't matter here because how it works in industry, first of all, you get an induction, right? Of course, you need to crack interview. I will be coming to that. After interview, suppose you got selected in any of the big company, big names. What happens? You will be going through an induction. After induction, you will be able, like you will be introduced to the leaders of the company, how the company runs. You need to understand the admin part. Then they will place you to domain specific training. Now, as a AI specialist or GeoAI specialist, whenever you are trained in a streamlined domain, if I propose a course today and I will teach you only agriculture or only disaster management, you will crash tomorrow. Tomorrow, if you get a chance in interview also, if you clear that interview also, you will fail in the multiple domain achievability. Like you won't be able to achieve that. How? Today I'm working in crop. I'm very suited. Suppose I got selected, everything is done. I got a proper domain training, right? Everything is done. I started work. I'm happy. Tomorrow, the agriculture client, the government they don't want to continue. But we got a very good opportunity in utility sector. Now the person who has done GeoAI specialization or GIS specialization in agriculture won't be able to shift to utilities. That's a bottleneck. But here in GeoAI part, if you know till the building of the models and the deployment, and there are a lot of containerization, a lot of orchestrations, we will be learning and introduced to a lot of terminologies, right, in this session. So stay with me. Domain applications, coming back to domain applications. So we need to be specialist in all, right? Coming to the infrastructure and deployment, guys, what you can see in your screen, big data. Now, a few days back only, I went for an interview. I will tell you my thing. They were saying that, Ulash, you are a GIS expert. You know, you have 13 to 14 years of experience. You are brilliant. They said me, it's no problems. You know AI. I've done my AI from IIT Patna, right? AI certification. So you know AI, everything is fine. Now tell me, if you don't know deployment and if you don't know how to make sure that it is like you don't know how to explore big data, you don't know how to do queries or geospatial databases, there is no use of you. If you know normal queries, it's fine. But what about big data? You need to know big data. Big data is the streamline for GeoAI. There are a lot of data sets because if we try to do anything from our machine, it will be stuck as a project. Again, I'm repeating you. Till you deploy it, then only it becomes a product, right, guys? So let's move forward. There are a lot of things to learn. Stay with me, like LLMs, multimodal AI, Gen AI, GANs, agentic AI, spatial RAGs, my favorite. GeoAI job markets, like everything I will explain. And of course, Dr. Arnav sir will also explain. So let me complete my part first, move forward. Yes, what is GeoAI, guys? Here we are explaining what is GeoAI. Very simple things. What is intelligence? If there is some reasoning capabilities, there is some logical capabilities, and a machine is capable of doing that, any algorithm is capable of doing that, that is artificial intelligence, right? And when we are taking this artificial intelligence into three parts, one is earth data, right? Earth science, earth data, where there is no coordinates are involved. Whenever we, like these are all sensor data, right? Whenever we get and amalgate it with any kind of coordinates, it becomes spatial data. Now you say me, if it is Earth data and it is geospatial data, what is GIS data? After this collection of these data in field, which I did in my early days, I was a surveyor also. So when you collect all this data, TS survey, DGPS survey, you collect coordinates, right? You do socioeconomic survey, household survey, right? All these data which comes in, when it is transformed into digital world through computers and technology, it becomes GIS, Geographical Information System. Now this whole scenario, what is GIS? GIS is just a tool, right? GIS is a tool. In one liner, I can finish. GIS is a tool which is used to store, edit, manage, and manipulate your data from anywhere in the world globally, right? Or from your system. It is used in analysis part. Now, when you insert artificial intelligence into it, it becomes much more smarter. It will have so much of energy, and it is called as powerhouse. Now, once I was discussing with Arnav sir, right? I was showing him my libraries. He is my mate. So while I was showing my libraries, I called him. I said to him that it is a powerhouse of GIS. How? Now, GIS data will be having, coming back to data, GIS data will be having remote sensing data. That means raster formats. GIS vector formats, everyone know, point, line, polygon, right? Then comes to raster. Then comes the attribute data. If we mix all of them and we put intelligence part into it, it can do wonders. The models which we are going to build during these sessions or during the Capstone project. So these models will gonna help not only in helping the human beings, it will be helping in predictions for generations. It won't help today. It will have an impact to next generations also, because it is predicting and we will take the actions on those predictions, those forecastings, and we will build the path for the next generations also. So GIS or GeoAI is very much important in this case to doing predictions, right? So GIS is of course there. It is just a tool which is analyzing. But what about predictions? What about forecasting? What about accuracy? It is much more accurate, right? So that's what GIS or GeoAI is. And looking by, I don't believe in reading presentations. I was a trainer, but in training, I was taught that please don't read presentations. That is boring part. Go ahead and like this LiDAR. Can you see this, guys? LiDAR, point cloud, GPS trajectory, topographic data, socioeconomic variable data. I might have covered almost all of them. Now let's come down to LiDAR data. Of course, there will be 3D LiDAR points, and we have certain things which, for an example, just a small example, there is a transformer named as YOLO V8 version 8, might be the recent one. So it can detect, and it can also detect all the objects, and it can also interpret the objects. So it helps us in foreseeing the future, right? If it helps us in ADAS systems, ADAS in the sense autonomous driving vehicle, like if we feed those ADAS systems with help of these transformers, it can do wonders, right? So in this way, even it can help in satellite imageries, classifications, any kind of analysis, what we are doing, it will be helping. So this is all about GeoAI. It helps in all the domains. It is a AI applied to maps, right? To make our map speak much more, right? Let's move forward, guys. Oh, some infographs. What is this? So this is an infograph which has been created by someone of us, and with help of what? With help of LLMs. Now, LLMs are large language models, right? They will be taking data from everywhere, projecting it, and they will be whatever commands prompt we were giving them. If someone is specialized in prompt engineering, that is very good. If someone is not, they can give normal prompts. The output will depend upon that. We will learn that also in LLM part. So as of now, what they are doing, all of us, like all the PhD people, the research fellows, you can see your screen. Even the AI/ML engineers, disaster management specialists, urban development analysis means the urban planners who sits in any government sector or private sectors, or even the most like the people who will be most beneficial will be academic people or the freshers, right? They will be much more beneficial with this program. So these are all the career opportunities in an overview, right? If we go in depth, we have a lot to talk. How, like now GeoAI. What do you mean by GeoAI? We know it's an intelligence amalgamated with GIS and all. Now, if we go in depth, what are the characteristics of GeoAI? First of all, the spatial awareness. Of course, we need spatial awareness. Tobler's first law, like it's a 1960s law. Now you will say, Ullash, if you are going by 1960s laws and you are doing GeoAI, you are saying that AI is the recent trend, you are talking so much. But what about why we are following 1960s law? Because Moran's law or Tobler's law, these laws are the basics. I will give you a very good example, you will understand. Suppose for a climatology or the climate stations, if we are trying to capture the climate, right? Very straightforward. We are trying to capture the weather of a station, weather of an area. What we are going to do, we are going to take samples. Weather stations will be fitted, or whatever sensors it has, it will be fitted in a small place. And it will take all the sensors as we will capture only for that area. Now, depending upon that, we will infer rest of it, right? So the more away we go, the characteristics will be lost. But nearby the station, it will be same weather type, right? For a desert also, the more you go away from a desert, right, you will lose sand. You will be started seeing arid region, semi-arid region. Then you will start getting plain lands, agricultural lands. It will go, the conditions, the temperature will also drop. That means the desert will lose its characteristics the more far away you go, right? So this is one or two laws which I have said you, but spatial awareness depends upon multiple laws which are as old as from 1960s. That's what I'm trying to say. Moving forward, multi-scale analysis. Now it is not depend upon a single domain 2D. It is not depend upon 3D. AI can go ahead with everything, like, right? AI can support both the domains. The algorithms which we build, it will be helping us not only for our recent trend. What is the recent trend, guys? We should know this. Drones, right? So the drone data is of course helping us, whatever data we are collecting. After this drone data, if we go with LiDAR data, if we go with more remote sensing data or the satellite images, aerial images, much helpful, panchromatic images, good in resolutions, right? Multispectral, multi-band images, you can be Landsat, Sentinel, whatever. So it has a multiple scale, right? You can understand the power. It can change the whole domain, whole scenario, right? Moving forward, the temporal dynamics, like you can see, it helps us in multi-data imagery, time series sensor data. That means not only dependent upon GIS or geospatial or Earth data, it can take data from anywhere, right? It will help us in understanding or help us in solution or providing the solution or decision making. This is a very important word in AI. Whatever we are doing is to make sure we are taking some decisions. The decision making of GeoAI is very important. Moving forward, you can see this on your screen that geodata encompasses raster, vector, point cloud, blah, blah, blah. These things means it is covering everything. Whatever you know, wherever you look in GIS, it is covering, right? Flood warnings, land use decisions, that is very good actually. So GIS is a person who is learning GIS, geography, let's start from geography. A person who is learning geography, or the person who is moving to information systems and making it GIS, the person who is doing learning Python, who is learning JavaScript, trying to build web maps, right? Web maps, very, very important, guys. So what happens at the end of the day? At the end of the day, we are trying to make something or build a model or build an algorithm which will try to help us reach the in-depth solutions for a particular domain. So this session will cover, like, it will be covering, Arnav sir will cover much of the domains. I will give you an overview and of course my specialization part. Moving forward, this is, guys, completely, you can relate to it. If you read it, you can relate to it. To understand the roots of geospatial data science, that's what GeoAI do. To unleash the power of GeoAI through predictions and forecasting, these two words are very important. Third is something where we grow together, we evolve together. GeoAI is not possible single-handedly. Not a single person in this whole domain, whole industry, all scholars, all students, all universities, all IITs. GeoAI is not possible for a single person to do anything. We are a social social animal, human beings, and we need to make sure that we work in team collaboration. And with help of GeoAI, our main target is to make sure the GIS community is evolving. At the same time, while evolve, it is making our world a better place to live. That means at the end of the day, we have to help the humanity, right? So that's what, moving forward, guys. Yes. Now we are talking about GeoAI expertise or GeoAI's professionals. There are, of course, certain prerequisites, guys. Of course, you need to be a GIS professional or GIS lecturer. Like, you need to have the knowledge of GIS. Apart from that, you should be knowing maths and statistics, right? A little part of probability, because most of our part will be predictions. Statistics and maths is required. Statistics, basic statistics like descriptive statistics, all the central tendencies, right? Mean, median, mode, these things. Apart from that, if you go forward, you have to learn a few descriptive statistics. That means you need to know all this. Moving forward, calculus is required a little part, not completely. Linear algebra. In linear algebra, we need to know the array part, right? Array. You can see the matrix, right? These matrices or the matrix will become an array later on while using certain powerful libraries. You can see these libraries, right? NumPy, Panda. So when these libraries are there, we are using them and trying to make our, like, whenever we are trying to write any program for any model, these libraries will help us to transfer our GIS or attribute data into data frames, arrays, because very straightforward, guys, our AI models which we build, or this NumPy, Panda array, these libraries, they don't understand your coordinates. They don't understand attributes. They just understand numbers, bytes. Computer works on bytes, 0, 1, right? So they understand numbers, and we will convert everything into numerical things. Again, this will be converted into bytes. Machine will do that for you. You won't need to do it manually. So these libraries are so powerful, it can do that and make it machine readable for our machine learning or deep learning or AI part. Everything should be done in Python. As of now, Python is going. Let's see if we can do it in Java or other part also. That depends upon scholars or scientists like you guys. So let us move. Of course, GIS is required. Now we are coming to the advantages. It helps in scalability and speed, guys. Those who are working in GIS, I will give a small analogy. There is companies currently in India, right? I won't take names. There are currently the companies which will be having 20 people, 30 people manpower, right? So they will be taking projects directly from Indian government or state government, and they will be trying to do it with traditional manual GIS. Now, if you hire 2 to 3 GIS programmer, they will automate the whole part. They will eat the job of those 20 people, right? And they will try to automate the whole thing using Python. Now, how is helping us here? They can do that in their own system, or they can give the delivery to the government. Like the owner will come, sir, they will approach the government, sir, I have completed the whole part in 3 days. I have just taken 40, 50 people once, give me the payment, right? I have done it. Now they will check, oh, it's fine. You have done it in 3 days, you get more projects. That is fine. That is still the automation part. Now, what about AI? What AI will do? Now, as an AI specialist, or if you are a DevOps, you will need some part of DevOps guys here. DevOps and AI, what it can do, it can build models which can be deployed throughout globally, right? Recently, I have built a model, and I will of course share that link later. I have built few models, recent models, which I'm building. I need to deploy that. If I don't deploy that model, it will become a project. I have repeated it again. I'm repeating it again. Till you deploy it, it will become a product. Industry currently want that type of people. They don't want project people. Very straightforward, guys. I am here for 14 years, and current trends, I gave so many interviews talking from my personal experience. These industry currently want people who knows end to end. This is what they will use in their job description. We want people who knows end to end, not only knowing theoretical knowledge, not only knowing machine learning, deep learning, AI. No, they want everything, the complete package. You can sell yourself in front of any companies only when you are a complete package. You know end to end everything, right? Only learning till deep learning or building a model in your machine won't help you. You need to deploy it. That helps us in their scalability. Like for an example, Amazon, if they take a product from you and they want to predict what will be the retail sale for next 10 years, you need to make sure that model is deployable and scalable throughout the world. Building a model in your system won't help. You have to deploy it through clouds. And as it is Amazon, you will deploy it through AWS, Amazon Web Services. So that's what we need to learn to make it scalable. Now, speed, of course, you know, right? When a 20, 30 people can lose their job for 2 people, as per my example. Now, what can AI do? A single person can do wonders, right? Moving to the pattern discovery. Now, this is something related to data again. If you are doing supervised, there are a lot of type of machine learning, supervised learning, unsupervised learning, reinforcement learning. Still a lot of learnings or types are coming up every day, we can see. But what they do, they understand the pattern. And if we understand the pattern, we can build future sustainable projects, future sustainable models, actually. Automation is, of course, I have spoken about. We can do feature extraction, road mapping, everything. Road mapping is a very critical part. Few companies only take projects. Trust me, I will tell you real life scenario. Few companies currently, they are taking projects where you just need to draw a line. You will sit, you will draw your line from morning to night. You won't learn anything. You will come back home. Are you a PhD or scholar to do that only? You will ask yourself. But GeoAI will change the scenario. Now you are impacting thousands of peoples. You are not doing a simple road creation. You're not doing a simple pattern understanding. You are doing something, you are building a model which can change the whole generations, right? That's the real power of GeoAI. And if I get a chance, I will show you a few models of mine. Decision support. Now, of course, whatever we do, building models, deployment, whatever you can see on your screen, what it is up to at the end of the day. At the end of the day, it is helping us to take a decision, and that too correct decisions, right? So let's move forward. Of course, there will be some disadvantages. I'm always worried about this page. This page is there. Of course, advantages are there, but more important is this limitations, how we can go ahead of it. Like for an example, of course, I said I don't want to read the slides. You can come down to any one of it and ask me. Today, I build a model, right? And I suppose for an example, very big bazaar, right? Big bazaar. My company has taken interview. They have given me a chance, opportunity. I'm working as a GeoAI specialist in Big Bazaar. Now, Big Bazaar will naturally give you all the data. Now, what you do? You will do everything, and suddenly one day your boss has said something, and you don't know that. Now, what you're going to do? You're going to put and copy the whole data, put it into an LLM, Gemini, and AI. Nowadays, most of the people does that. They create infographics. They create all the data and everything from LLMs. But they are forgetting that people, those who are doing, actually, we are forgetting ourselves. We need to be ourselves first. We need to use our own brain, our own knowledge. Depending upon AI will be very, very costly in future, because AIs they are artificial brains. They are not human brains. They don't have logical or reasoning capabilities. If they have also, they don't have intuitions. Intuitions, like they don't have six senses. Like human beings have certain things to sense a lot. It will, of course, it will come after a lot of time, like after 4 or 5 years in this domain, then it will come. But whenever you upload, coming back to my topic, whenever you are uploading that data, big bazaar data in LLM, what will happen, guys? That data will become public. Now, anyone searching from anywhere can get access to big data. Sorry, big bazaar's data. What happens? Now, the competitors of Big Bazaar, for example, I don't know who are the competitors, Big Basket example. So if Big Basket wants, it can take all the data of Big Bazaar and make that company bankrupted. They'll steal the data. So that's the risk of ethical practices, right? Ethical and privacy concern. It is nowadays, you can understand this military intelligence, maps. There are a lot of maps which are not being shown in Google Maps also, Google Earth also, or no satellites can detect that, because in those areas, those are secured parameters, military zone, defense zone, armaments where we create, like where we manufacture guns or ammunitions, those areas, nuclear facilities, right? So those areas, maps of those areas can be a threat. If someone creates a map and they upload it in LLM or anywhere in Google, wherever they publish it, it will become a huge deal. So for security reasons also, or privacy concerns also, we are using this. Now, interpretability deficit, it's, you can see in your screen. Sometimes what happens, deep learning people, if deep learning is very good, machine learning, deep learning, they are very good, they are smart. But sometimes you should be, as a GIS professional, I'm taking all, right? As a GIS person, or just don't consider yourself as a scholar or doctorate or student or professional. Just think that I'm a GIS person. It's my domain, it's my life, it's my world. So what do? You will be spending time on your reasoning and increasing knowledge every day. Now what happens? Sometimes deep or neural networks, very few people know what happens inside neural networks, how the neurons, how they talk among each other, right? So there will be complex deep neural networks, and they will take out the computation computes or the results at the outputs at last. But as a GIS person, you should be able to interpret that. Now, yesterday I was giving one lecture in one area, like one institute. What I said, right? That's what I faced in my real world. Everything with what I say is from my real world experience. Dictate AI. Tell the AI what to do. Don't ask AI what to do. Ask AI how to do. How to do, you will ask, it will give whatever output. You have to analyze that output. That terminology is called as HIL, human in loop. Moving forward, so GeoAI in GIS and remote sensing, you can see how it is helping the human beings. Like what are the fields, crime, health, LULC, and we use a lot of techniques, CNN, transformers, encoders, very, very interesting things. These can help us a lot. Object detection, YOLO, one of the great. Semantic instances, we use our normal machine learning techniques to do semantic instances, all these things. Multi-temporal sentinel, these images like these, we can use these images to see change detection, urban sprawl. Last 20 years, how Pune, the city has grown. Pune, currently how it was, 10, 15 years back, how it was, sorry, 5 years back, how it was, 10 years back, how it was. You can do a complete visualization and predict the future, predict how it will be, right? Machine will learn the pattern and it will put the same pattern to next. So we also have certain techniques which are very, very important, like GANs and all. We'll come to that later. Ensemble models. These ensemble models are type of machine learning models. Ensemble is a method where we merge all the models and try to win some particular model. For an example, decision tree. It fails. Random forest. It fails. What happens? We try to merge all these models. Hundreds of decision tree can make a random forest, right? Gradient boost, normal gradient boost failed. Then we use XG boost or light GBM. Like in this way, these ensemble models will be helping us in learning, in machine learning part. SVM, of course, the support vector machine, this is much better and it gives very good results sometimes. And of course, the spatial ML models, these are all GWR. So till here, we are creating models, till algorithms for machine learning only, right? These are techniques. Actually, these are all techniques, right? This is not AI. I will repeat that. Moving forward, deep learning. Now, you want to eradicate the feature engineering, right? The feature engineering part, you want to eradicate that and you want to automate the whole part. You will just give the input. You want an output. You will say that output to the machine. You will code it and you will also ask the machine, I want to use CNN only for image classification. I want to use encoders or decoders only for agricultural parcel identification. Or I want to understand how many agricultural parcels will be there in our next land or our next area, right? So in this way, it helps us. Recurrent, there are a lot of models. You can see LSTM, long short-term memory, right? It is also very, very useful. Recurrent transformer, that means, I will tell you guys what happened. This transformer model, when it entered the scenario, this what transformer, don't go by ChatGPT. When you become an AI expert on AI, GeoAI professional also, you will start hating or you will don't like ChatGPT at all, because that's doctors don't like to eat medicine. That's the thing, right? So moving forward, these are all GNN. It helps in road graphs, river network, right? Moving forward, the bonding. Now in academics, what happens? We think theoretically. We will, of course, use these models, UNet, PointNet, GeoTransformers. We will, of course, use these tools. I have one of my mentee, right? One of my mentee who came up to me and said, UG, he asked me, he called me sir first. I said, there is no doctorate, there is no sir in our industrial domain. We call everyone by name. He was saying, no, sir, how can I call you by name? I have to call you Dr. Ullash Ghosh. I have to call you Mr. Ullash Ghosh. So that's the thinking. We are all same in industry. We are all doing service at the end of the day. Someone is the boss. He is paying us as per our work or as per our talent. So nothing to worry, guys. Let us change our thinking toward and the approach towards the industry. Let us build communication skills first. Let us brush up our GIS skills, and let us get updated with the GIS, what is going on. And of course, GeoAI will help you. GeoAI is the addition of the add up which changed the whole system, whole scenario. Coming back, this GeoPanda, Rastario, we use all of them. Of course, peer to review, we use that. So whatever you can see in your left hand side, these are all what you guys are doing, like what academic people are doing currently. And these are the big industries, what they follow. ESRI, Google, Microsoft Planetary Computers. I love this. So Planet Labs, Maxar, IBM, AWS, Azure. So these are all industry companies. They will be doing different roles in their system. Now I will give you a example. IBM or AWS or Azure, even GCP, it is missing here. GCP is Google Cloud Platform. AWS, Amazon Web Services, they will have different type of web deployments. Now, ESRI is we know only ArcGIS. Oh, sir, there is a software named as ArcGIS. We know till there, but we can do whatever we want inside ArcGIS. But these are all paid versions. S3, you have to, don't get into cracked files, right? These are all paid versions. ESRI, you have to pay certain amount to the ESRI for your paid license. And your GeoAI model lives inside that. It is not scalable. If it is scalable also, that also has to be inside ESRI model. You cannot go to ESRI and you cannot deploy in Amazon Web. If you create a model in ArcGIS, you cannot deploy in Amazon Web Services. And if you deploy also, there is some terminology named as MCP, right? MCP will be helping us recently. So there are a lot of new things to learn, guys, in this thing, because both goes together. There is a bonding. Just you need to make sure, brush up your skills and just move ahead. That's it. Now these are all job. Now, a very interesting thing in this presentation is that you can see the salaries. So this is the base level starting salaries, 3 to 4 lakh, 5 lakh rupees entry level they get. 8 lakhs, very hardly few people get, because I'm telling you from my current experience. Of course, 8 lakhs, very few companies they can afford to give for the entry level. Like bigger brands, Google's, Amazon, they will be giving. Now, GeoAI skills. If you are a GeoAI, what happens? From a fresher, you enhance to a GeoAI, you learn the course, you can jump to 6 to 14 lakhs per annum, right? By just amalgamating the machine learning part. Coming down, satellite images. We all know satellite images. We all work in bands. We can pass infrared, normal rays, normal red. We all know LiDAR. We all know sensors, everything. But that is coming only as a satellite data analyst. If you do this course, or if you are interested, if you enroll, then if you complete this GeoAI, not this course, if you do this GeoAI, right? If you know this GeoAI, your scope will increase. You can be at least 12 lakhs or 5 to 6 lakh. More than that, guys, at least 12 lakhs you will get in satellite data analysis, right? These are all averages. These are not accurate figures. These are all average or estimates, right? Moving forward, field ground. Like now you are a surveyor. If you start learning GeoAI, you can become, you are building models. You will go into your own domain. I want to build something which can help in surveying. I will build a model. I will insert it into my DGPS so that it can help enhancing my survey skills. You are specializing. So it's very easy for a company to pay you 9 lakhs for that. So this is how our domain changes. Now, this is for the mid or advanced career path, means you have become a little advanced. You have worked for 4-5 years. Now you're incorporating GeoAI inside your domain or you're getting upskill, then what happens? Few companies like RMSI, Genesis. So these guys can give a salary of 8 to 20 lakhs. That's what it is saying. Urban planners can go ahead. Hydrology or watershed management specialist in these calls, they can also go ahead. Biodiversity, forest, GIS people, they can also go ahead. Academic and teaching professional, this is most of our crowd, which I have seen few people. So I think most of scientists are there, scholars are there. We can always go ahead with GeoAI and expand, and we can of course make sure we are teaching GeoAI to them, to our industry. You can apply as corporate trainers. There are freelancing trainers, right? Of course, GeoAI specialist, you can see, of course, GeoAI specialist, geodata scientist, or remote sensing AI specialists are there. Apart from all this, we have been listening to all this for last half an hour. Now, apart from this, you can also become a GeoAI professor or GeoAI. You can build your own schemes. You can approach industries. I have this knowledge. I want to just give me one chance, right? There are a lot of industries, they are currently doing this GeoAI thing, but lot of academic people, IITs and all. But as you learn this course, you will be specialized in professional world. You, of course, you can select academics that will be very few in number. That's the problem. But if you are a professional, you know how to deal with real life problem, you know how to do decision making, then these knowledges will help in your CV as well as you can showcase it. And most importantly, guys, at the end of the day, you're helping someone. You're making our life better because our work is very, very important. That's what I believe. I work in that way. I always take care like how impactful is my work. And I am so much confident today that this climate, disaster, precision agriculture, and research scientists, this is research people actually, how much they are getting. I'm confident that after a few years, this GeoAI will be a boom. Currently it started, and after 1 year, 1.5 years, all will be searching and seeking, all industry people, all companies, Google, Amazon, all the big names, right? Microsoft, they will go ahead and search for GeoAI professionals a lot. Like it already started and it is growing. And you can choose these career paths, right? Of course, in your company, you will be told as a disaster risk or early warning specialist. Sorry, you will be told as a GeoAI specialist. But in reality, what you are doing this. You are doing this domain. So these are all domain specific. But my mantra or my opinion will be that this is, of course, there. You can become a domain specific. But try to learn till the basics, deployment, containerization, and maintenance. After deployment also in cloud, we need cloud maintenance. If you learn all this, and domain will not stop you. You can be an expert in everything. Guys, I am not a specialized in any domain. I can work in any domain. So these are the pathways and certification part. Pythons and spatial foundation. After knowing or reading all these libraries or from VS Code, these are platforms actually where you can learn geographic data science with Python, Ray, and Ensemble. Python for geographic data analysis taken in. So these are step by step. One is the spatial foundation. Then comes the machine learning and GUI core, because guys, knowing the data of machine learning, it is different from GIS data. I am repeating. GIS data, of course, we will use, but the data formats or the datas which we use for machine learning or GeoAI is little different. We will come to that. Of course, we will go ahead with cloud deployments. So moving forward, I will, of course, Gayatri, I'm done. So guys, I will come back after a break. Till then, Arnav sir will take over. Gayatri, are you there?
Yes. Yes, sir. Yes, sir. Okay.
So I'm stopping my presentation. You can go ahead.
Yes, sure, sir. So thank you so much, Ullas sir, for making this session really a fun and helping us to understand high demand career opportunities with GeoAI and industrial scenarios. So, friends, Dr. Das discussed with vision to GeoAI, and Ullas sir has explained the market demand of GeoAI. Now let us look at the how and where part of it. So how do you people can learn these GeoAI skills? So for that, I invite Dr. Arnab Ghosh, sir, faculty at AIGR, to discuss the academic syllabus and content which comes under GeoAI. Dr. Arnab Ghosh is a dedicated water resources professional with a PhD in water resources engineering from Jadavpur University. His core competencies lies in numerical modeling like HECRAS, 1D, 2D, Mike 11, SWAT, field data collection, and employing Python and R for data analysis and predictive modeling of hydrological processes. His research, detailed in several peer-reviewed publications, quantitatively analyzes riverbank stability, bridge scoring, sediment yield, and flood inundation. As a former senior researcher and current hydrology consultant, he has successfully led and contributed to industrial and government projects concerning environmental impact assessment, EMP studies, dam safety, water availability, and wetland evaluations. Today, Dr. Arnab sir will break down exactly what the GeoAI training includes, from spatial RAG engines to IoT early warning systems. He will demystify GeoAI for us, explaining its core components and what attendees can expect from the learning pathways offered in this domain. So, Dr. Arnab Ghosh, sir, please guide us through the curriculum.
Okay, madam. Thank you, everyone. So actually, I am sharing my screen. Okay, hope it is visible to all of you. So welcome, everyone, and
Yes,
thank you for joining this webinar on GeoAI. Before we dive in, let me ask you a simple question in portions of academy, obviously. And what if the next breakthrough paper in your field, the one that gets cited hundreds of times, the one that shifts how we think about an entire problem, is waiting to be written by someone who combines deep domain knowledge with the power of AI and satellite data? Okay, so that person could very well be sitting right here among all of you. I think this course is designed for exactly that ambition. Whether you are a PhD student looking for a competitive edge, a faculty member exploring new research directions, or a professional transitioning into geospatial intelligence, this program will equip you with the full technical and conceptual toolkit to the cutting edge GeoAI research. We are going to cover mainly three major tracks in this course. The first one is the technical track, covering the Python geospatial stacks, cloud native data, and real world applications from crop yield predictions to flood mapping. Then the deep learning track, where we will build UNet models from scratch, explore explainable AI, SAR transformers, and point cloud learning. And the big data track, where we handle planetary scale data with the DAS, Spark, IoT pipelines, and real-time early warning all over it. But more importantly, this course is not just about the learning tools. It is about learning how to think like a GeoAI researcher, how to frame your problems, choose to write dataset, publish in the right venues, and build a portfolio that gets noticed in the global GeoAI community. So let's begin. Let me start by showing you the ammunition you will need, the dataset, the benchmarks, that form the backbone of every serious GeoAI researcher. So here is something most early career researchers do not realize. The dataset you choose can make or break your paper. If you train your model on a well-known benchmark and beat the state of the art, even by a small margin, that is publishable result. But if you use an obscure dataset with no comparison baseline. Reviewers will struggle to evaluate your contribution. Knowing these benchmarks is not optional, then it becomes the strategics. Then there are various kinds of big libraries in GeoAI, like Big EarthNet, like XVD. These aren't the synthetic. This is the real world devastations. Annotate so your model can learn to detect it. And here is the secret weapon. Your competitions, SpaceNet, IEEE, GRS's Data Fusion Contest, Kaggle, Zindi, these aren't just coding exercise. They are career accelerators. Winners get cited, recruited, and noticed always. And if you want visibility in the GeoAI community, and this is the fastest path, I think. Now that you know where to find the data, you need to know where to publish your findings in academic scenario and who to network with. Let us look at the research landscape area. Okay, I want you to think about something. Like if you write a brilliant paper but submit it to the wrong journal, what happens? Like best case, it gets published somewhere nobody in your community reads. And in worst case, it gets desk rejected because it does not fit the scope. Knowing the publication landscape is a superpower of academia. Now let's talk where this research lives. If you are serious about academic GeoAI, you need to know your publication landscape like you know your own neighbor. IEEE TGRS is the gold standard. This is where the field's most rigorous methods land. Remote sensing and environmental lens towards high impact applications, perfect if your work solves a real problem. And when GeoAI breakthroughs go mainstream, mapping poverty from satellites, predicting deforestations, they end up in Nature and Science. Okay, so in this configuration, your geospatial expertise in those rooms in a superpower because most attendees, there are computer scientists who don't understand the geography. And that's your edge in this criteria. So journals and conferences tell you where the community gathers. But what tools does the community actually use? Let me show you the complete software ecosystem. And this is the ecosystem. Think of this part of your toolbox. Just as a surgeon needs to know every instrument on the tray before stepping into the operating room. A GeoAI researcher needs to know the landscape of tools before starting a project. You do not need to master everything on day one, but you need to know what exists so you can reach for the right tool when you need it. Imagine this is mainly the periodic table of GeoAI, according to some researchers, and every element here is a tool that solves a specific problem. And your power comes from knowing how to combine them. At the base, you have your spatial processing layer like GeoPandas, Rasterio, GDAL. On top of that, your machine learning engines like PyTorch with TorchGeo, Hugging Face for foundation models. Then the cloud layer, the Google Earth Engine. I think you know already, the planetary computer. This let you process the entire planet without downloading a single file. And finally, the presentation layer, the Streamlit, the Kepler Geo. Because a model nobody can interact with is a model nobody will fund. We'll be working across all 4 layers in this course. By the end, you won't just know these tools, you will know when to reach for which one. And this is the perfect scenario for your academic research. Now let us leave the overview behind and enter our first major track, the technical track that I first told you. We begin with the most fundamental skill, the mastering Python for geospatial analysis. Actually, I always tell my students one thing, that if you cannot load, transform, and visualize spatial data fluently in Python, you are not ready for GeoAI. It is like trying to do machine learning without knowing NumPy. This module gives you that fluency in this scenario. And this is where you roll up our sleeves. Python is generally a lingua franca of GeoAI, frankly speaking. And if your stack isn't solid, everything else falls apart. I want you to think about it. GeoPandas, that is the spatial spreadsheet. Rasterio, your satellite image reader. TorchGeo, that is the bridge between remote sensing and deep learning, are also there. An advanced technique I want you to remember, spatial indexing with art trees are also there. When you are joining millions of points to thousands of polygons, the difference between an R-tree spatial index and brute force is the difference between 3 seconds and 3 hours. That's not an exaggeration. And you have mastered the vector data on your local machine. But what happens when your dataset is too large to download? That is where cloud native geospatial computing comes in. So this is the one. Here is a particular portions of reality check. The Sentinel-2 archive adds roughly 1.6 terabytes of new data every single day. If your workflow requires downloading data to your laptop before processing it, you have already lost. The future of GeoAI is a cloud native, and this module teaches you how to work in that within future. Actually, here is the paradigm shift is appear. The data does not come to you anymore. You go to the data. This is the process. Cloud optimized GeoTIFF COG is the file format, lets you just read just the patch you need to the satellite functions. All other functioning problems are there. And only those pixels, there are several kinds of pixels are also there. And there are no downloads, no DSpecs issues in this format. So combine this with Stack, a universal catalog system, and you can search across NASA, ESA, and Microsoft's entire image archives with 3 lines of Python. Then visualize the result in Streamlit or PyDeck, and you have a shareable dashboard in under an hour. This is how modern geospatial research is done, and this is what we will build together in this course. Let us now see these tools in action on a real-world problem that affects billions of people, predicting how much food our fields will produce. So this is the part. Here is a number that should keep you up at night, that global population will reach nearly 10 billion by 2050, and a food production needs to increase by about 60% to keep up. Now, here is the good news that GeoAI can tell us months before harvest which fields will underperform, which regions face food insecurity, and where interventions will have the most impact. Crop yield predictions is not just an academic exercise, it's a national security issue nowadays. And if GeoAI has a killer app in this agriculture, is this the predicting how much food a region will produce before the harvest happens. Think about the implications. Governments can prepare food reserves, markets can stabilize prices, aid agencies can act before famine, not after. The magic is in the feature. A single NDVI curve across a growing season tells you the story of the crop. When it emerged, how healthy it was at its peak, whether it experienced drought stress, layer in soil data, rainfall, temperature, and suddenly your model understands why yield varies from field to field. But here is the trap most beginners fall into, that is the spatial leakage that we also covered in our course format. And from predicting the food production, let us move to understanding what covers the Earth's surface and how that connects to one of our most precious resources. And what is? That is the water. Every time you eat a bowl of rice or wear a cotton shirt, you are consuming water. Not just that water that was used directly, but the entire chain of water inputs from field to finished product. The concept of a water footprint quantifies this, and GeoAI is how we map it across the planet. But it all starts with one fundamental question: what is growing and where? Land cover classification sounds routine, but at scale with multi-source data and real-world accuracy requirement, it's one of the hardest problem one's radar. Why? Because clouds block optical sensors, and in tropical regions.
So Lassa is there. So it is better to wind up. Already we have about 2 hours. So
Yes.
Lassa, can you summarize it?
Yes, of course. I think Arnab might be having some issues, right, Dr. Arnab?
Yeah.
So let us quickly conclude this thing. Yeah, Arnab sir is having some network issues. He has called me. So, guys, so let us go ahead, right? Later, when Arnab sir will join, we will hand over to him, right? So what he was saying that like that we will be building at the end of the day, we will be using certain techniques. Of course, the techniques of raster, then we will go ahead with cloud deployment, we'll go ahead with step by step building the models and watching it through, like creating the dashboards. And I believe everyone can see my screen. Gayatri ma'am, can you see my screen?
Yes, sir, it is visible.
Okay.
Yes,
So
yes.
Sir,
Actually,
okay,
my network is problematic here. I'm
you can
sorry
go
to
ahead.
say.
You can go ahead, Arnab sir. I'm just sharing my screen. I'm stopping the sharing.
Okay, sorry for the problem. Actually, my network is problematic here. So, okay, so actually,
Anup sir,
yes, yes.
try to conclude within 10 to 15 minutes because already 8:27 is there. So it's a big course we know, but we should conclude within 10 to 15 minutes. Okay.
Okay, okay.
Okay, okay, thank you.
Okay. Actually, in case of a problematic sorry for the problem. And in our course, we also dealt with some flood and modeling with some hazard problem. And actually, imagine you are a chief scientist advising state government on disaster preparedness. The chief minister asks, where will the next flood hit? You run your XGBoost model and it produces a beautiful susceptibility map. The ministers then asks, why does the model says this valley is at high risk? If your answer is the model says so, you have lost your credibility. If your answer is the model defines your topographic wetness index and proximity to the river as the dominant drivers, which aligns to your hydraulic theory. And here is the SAP plots showing exactly how each factor contributes in this association. So in this research, the SAP and LIME solve this problem. SAP tells you globally which factors drive by flood risks, and LIME goes local for this specific pixel part. Speaking of hazards in mountainous region, let us problematic in also in landslide probability, and the landslide concepts are also dealt with this course. And let us look at one of the most catastrophic idea, that is accelerating due to climate change. That is the glacial lake outburst system. I think it is one of the most important part. A globe-triggered flood in Uttarakhand in India in 2013 killed thousands and devastated entire valleys. In 2021, a similar event in Chamoli district caused a massive destruction. These are not once in a century events anymore. They are becoming more frequent as glaciers retreat and moraine lakes expands. GeoAI is our best tool for monitoring these tricking time bombs and warning communities before they burst in this area. So we dealt with some Earth observations data. And after that, we put some globe-centric model through GeoAI and its impact analysis with the predictions how they becoming more vulnerable in near future. We have also covered powerful applications in the technical track. Now let us shift our gears to the engine that powers the most advanced GeoAI system, that is the deep learning. And this is the deep learning track with UNet and PyTorch. If I choose one deep learning architecture that has had the most impact on Earth observation, it would be the UNet. Original designing for biomedical image segmentation, UNet turned out to be the most perfectly suited by remote sensing, and it handles the limited training data carefully. It preserves the spatial data through skip connections, and it can be trained on a single GPU. Understanding UNet deeply is not the optional in GeoAI, and it's foundational. UNet is your general purpose tool, but some applications demand specialized spectral AI. Let us look at two fascinating ones, mapping the ocean's carbon sinks and finding the minerals that is in underground. These two applications might seem unrelated. One is about preserving ecosystem and other about the extracting resource. But they share a common thread. Both rely on exquisite spectral sensitivity of AI to detect things invisible to human eye. In mangroves, AI reads subtle spectral bands to identify the minerals without ever touching the rocks. We have seen how AI learns the data alone, but what if we could teach neural networks that laws of physics? That is the promise to the physics-informed machine learning, especially on the two important environmental modeling, rainfall runoff and groundwater. Physics-based model encode our understanding on natural laws, conserving of mass, that is the Darcy law, the Saint Venant equations, but they require extensive calibrations and often fail in ungauged basins. Data-driven ML models learn patterns from data and generalize well, but they can produce physically impossible results. Negative stream flow, water appearing from nowhere, groundwater levels rising without any recharge. Physics-informed machine learning resolves the tension by embedding physical laws directly into the neural network. It is one of the most exciting development in geoscience, as well as GeoAI too. From modeling water flow, let us zoom out of the map water scarcity across entire regions, an increasingly urgent challenge over time. 1/4 of the world's population faces extremely high water stress. By 2050, this could increase to nearly half. These are not abstract projections. They represent the real communities, the real farms, the real livelihoods at risk. GeoAI enables us to map water scarcity at spatial and temporal resolutions that were previously impossible, turning global concern into locally actionable intelligence. Let us now look at 3 applications domains that span the entire spectrum of Earth observations, from concrete jungles to crop fields and to ocean floors. GeoAI does not care about the disciplinary boundaries. The same deep learning architecture that maps urban heat island in Mumbai can detect crop disease in a wheat field in Punjab and identify the plastic debris in the Bay of Bengal. What changes in the data modality, the spatial scale? That is the domain, the expertise, but the underlying AI methodology transfers beautifully. We have built models that predict many things, but can we explain why they predict what they predict? And can we move beyond correlation to actual causation? And this is the frontier. So on that basis, there is a sentence I want you to remember throughout your career, that correlation does not simply causations. Every data scientist knows this phrase. Far fewer know how to actually move to the correlation to causations in rigorous way. And this module teaches you both explainability on the basis of understanding what your model has learned and causal interference. And some of the most powerful data from understanding Earth surfaces comes out from the optical cameras, but from the radar. Let us explore SART data. That is the main transformer architecture that are revolutioning how we analyze it. Over tropical regions, the Amazon, the Southeast Asia, the large parts of the India during the monsoon, cloud cover can exceed 80% of the time. If your GeoAI model only works with optical data, you have model that fails exactly when you need it most, during the rainy season, when floods are happening, crops are growing, decisions need to be made. Synthetic aperture radar sees through clouds, works on the night, and provides the structural information unavailable in your optical imagery. In our course, we have been working with regular grids, rasters, and pixels through these kinds of data. But what if your data does not live in a grid? What if it is a network spatial relationship? And this is the portion of the geometric deep learning. You have a map of every poverty transactions of your city. The price of a house depends not just on its own features, size, age, number of rooms, but on its neighbor features and prices. This is the spatial dependence, and it violates every assumptions of standard regressions. Spatial econometrics has dealt with these kinds of formations decades using the spatial weight metrics. Geometric deep learning are also there with the help of some GeoAI research. From 2D graphs, let us leap into the third dimensions. LiDAR. You already know it. Point clouds gives us the most detailed 3D formations about the Earth's surface. Learning directly from this, understanding the 3D point of visualizations with the XYZ format. The point cloud is not an image. It has no pixel, no grid, no regular structure. It is a raw, unordered set of XYZ coordinates. That is, standard CNNs cannot process this data. You need architecture that can learn directly from unordered point sets. And this is one of the most exciting intersections of 3D computer vision and art science in this regard. And we have covered deep learning architectures for every data type, rasters, graphs, point clouds. Now let us enter the final track, that is the big data. Learn how to process the data in a planetary stack. If you wanted to compute a simple NDVI time series from all Sentinel-2 data over collected, you would need to process roughly 50 petabytes of your data on a single laptop. That would take approximately 200 years. Or you could use your tools in this module and do it in hours. The Pangeo ecosystem built around the DASK, X-array, stack is how modern geosciences scales from the experiments on a laptop to analysis of the entire planet system. X-array and DASK handle raster array data beautifully. But what about the billions of vector records, GPS traces, building footprints, global OpenStreetMap data? For that, you need the Spark. Actually, Google has done the same. In OpenStreetMap contains billions of spatial features. Processing these kinds of data on a single machine is simply not possible. Apache Sedona, the leading geospatial extension from Spark, distributes the spatial operations across the cluster nodes, making it possible to perform the spatial joins, contaminate in a test and distance calculations on datasets. Big data does not only come from a satellite and database, it also streams in real time from sensors on the ground. And let us look the most important in this academic session, that how the IoT architecture fit with GeoAI models. A satellite passes over your study area once every few days, but a flood can develop in hours, a landslide in a minutes, a soil liquefaction event in a seconds. The gap between satellite overpasses frequency and the temporal dynamics of hazards is where people die. IoT sensors networks bridge this gap, providing continuous real-time ground observations that feed GeoAI models with the temporal resolutions needed for effective early warning. We have sensors streaming data, models making predictions, satellites watching from above. Now we need to bring it all together into a single operational platform that decision makers can actually use. And this is the final piece, real-time dashboard and early warning system. Let me end this academic session with the most important part. Everything we have learned, the dataset, the models, the architectures, the distributed computings only matters if it reaches the people who need it. A flood susceptibility map sitting in a Jupyter notebook does not save lives. A real-time dashboard that shows a district collector exactly which villages need to evacuations in the next 6 hours does. And this module is about the last mile from model output to the human actions. The well-designed dashboard architecture like Fast API, PostGIS, Redis, WebStockists, all are performing in these cases. Particularly, these are not the research prototype. They are operational system built on exactly the technique we will cover in this course. So that's the academic track. The dataset, the tools, the method, the applications, scalability, deployment, all of it. Every module is designed so that by the end, you don't just understand GeoAI, you can do GeoAI, publish it and deploy it. I look forward to going through this journey with you. And this is the total academic portions. And I think this is the part that is over to Ullash. Gayatri madam.
Yeah, thank you so much, sir.
Okay, can you guys please confirm?
Yes, madam, you're visible.
Yes,
Can you guys please confirm? Can you see me, right? And I will just
hello,
take
Ullas sir.
5 to. Can you hear me?
Yes, we can hear you.
Yes, I was just saying, I need only 10 to 10 minutes. I know we are already running late due to certain disturbances. So let's see, we'll just try to complete in 10 minutes and does a quick walk around. And I will make sure it's interesting, just 10 minutes, right? So I believe you can see my screen, right? Okay. So guys, welcome back. That was a very nice in-depth in-depth lecture by Dr. Arnav Ghosh. Let us move forward, and I will really make it very fast. We'll just walk around it and try to make it very fruitful for you guys, right? So, of course, we are diving into industry specific. Of course, we are diving into domain specific. We are trying to know all the libraries. We are trying to do machine learning, learn deep learning, the library stacks, the technology changes. We are into cloud deployment. cloud technology, cloud data format, everything is understandable. But the current trend is the most important. That's how you can secure your job in GeoAI, right? So moving forward, this is LLM, the large language models. If we are trying to build any Geo LLM, right? I have personally built few Geo LLMs. It will be a multimodal, like we can merge all 3 to 4 LLMs and get out of a single inference, right? If you are trying to build a model which can go ahead and infer, for an example, if you are trying to build a flood model and you're taking the brain or logics from some LLM and you're trying to infer and merge all the LLMs into a single output, then we can go ahead and do this large language model stuff. We will be going ahead with end to end of this large language model, how to build it, how to go ahead with this. And you can see the infographics. This is the content generation chatbot, exactly how it is working. And this is also simplified, like how it is doing step by step, how it is reaching. Like after the deep learning, guys, what we do, right? After the deep learning, we will be going ahead with creation of a PKL file, the memory, the artificial intelligence will be stored in it. That's how we will proceed. That PKL file or .pkl file or like that memory will help us in going ahead with doing predictions, doing understanding what will be next, right? So moving forward, multimodal models, of course, we will be using like if we talk, we will just say the map, where is how much distance is this school from another school? It will give us the reply, right? These are all speech. Now, apart from speech, you will type in text where how much distance is school number A to school number B. It will type, it will also give the examples. So it will be taking multiple inputs and giving you an output. Whatever is inside going on, we will of course know that in our classes or in our theories. And it will be not theory class, guys. We are dedicating most of our time in practical learnings because this is a program which can enhance and which is trying to make you industry standards, right? So this is the infograph, how the LLM are working. My favorite is this Llama. Llama is also very good here. Introduction to GenAI. Now something great came in, the GenAI part. Now the industry is currently looking for GenAI because if there is generative AI, full form is generative AI. The word itself says that we are generating something which is not there and which is we are predicting and we are generating some synthetic data. So this Gen AI application in GIS or in GeoAI is changing the scenario. We are using certain models like you can see variational autoencoders, diffusion model to do all this. How, what to do? We are doing cloud. It can help in cloud removal. It can cloud removal means image disturbances, climate downscaling. These are all the applications, right? Moving forward, this is the overview. You can see it. Now, guys, this is something called as GAN. GAN means generative adversarial networks. What it does with, like, suppose you gave it fake data, there is a generator, it will take the fake data, it has certain neural networks connected inside it. There is another fighter, actually, another competitor inside it. It will say that, no, your data are not fake. So they will try to validate each other. At the end of the day, it will give one result which you need to validate, right? Encoders, of course, it encodes the music, like it can encode the whatever sound you are saying. It can encode the text, and it can also encode any images or any visuals you are uploading, right? So after that is encoders, it will be going inside again, certain mathematical rules will be applied. And at the end of the day, there is a decoder who will decode and give the output. That happens inside VAE, right? So you can see there is a deep dive over here, how the GANs are working. And if you see, like this is how it works. You give a satellite images with super resolution of satellite, it can create actually a better resolution immediately. This happens when there are cloud, there are image tiling or image. Like sometimes what happens if the satellite is taking wrong images, there will be disturbances. So it has so much of power that it can make it 100% the resolution be super high, right? And you can see from all these examples also, very much useful for land covers and of course predicting land cover, right? Only land cover is coming back, it will take you to GIS, but how it is different, it can help you in land cover synthetic or predictions. So these are all GANs, guys. These are the normal different, like the complete journey of GANs. It's written and described here. As we don't have time, we will move forward a bit. Agentic AI. Now, this has changed the scenario in whole domain. Currently, if you are a GIS person, how a company works? A company work, someone will be doing a coordinate specialist. Someone will be coding. Someone will be GIS complete expert, the manager. So now you don't need that. You create agents inside your system, inside cloud, you create agents. One agent will be deployed for reasoning. One agent will take care of all the satellite images, all the raster images. One agent will take care of the application, converting into GIS data. Another agent will calculate, and another agent will do analysis. At the end, another agent, the final agent, will do the prediction. And we need to take that brain from any LLM and through API keys, guys. So that's how the agentic AI works. This is the whole scenario. You can see from the graphs. Multi-agents, that's what I talk about. Someone is creating, like you can see planner, specialist, critics. You can give your own names also. It is not mandatory these names has to be there. This is just an example. You are creating a multi-agent framework where you don't need to do anything. You will just upload the satellite image. At the end of the day, it will give the prediction. It will give you all features. It will give you all NDVIs or whatever indices are there. It will take it out. It will extract the features. Or everything is automated. At the end of that, it will do predictions also if your data is enough, right? And after this, we do orchestration. There is something called as orchestration. Now this multiple agent framework, they have to talk with each other, right? How they will form a cycle, how they will work. There has to be proper orchestra. Music is played by orchestra, right? So this is a kind of GIS. GIS or GeoAI will only be played through orchestration by these all agents. It helps in our...
Hello, Ullas sir. Are you there in meeting?
Probably not.
So let me take this meeting towards its end. I want to thank... Am I audible? Yes. I want to thank Dr. Arnab Ghosh sir for briefing us about the academic curriculum of GeoAI. I also want to thank Ullas sir for giving us overview of LLM, multimodal LLM, Gen AI, GeoAI pipelines, and other things. As towards at the start of this meeting, Dr. Das rightly said that we obviously need some guidance and hand-holding to learn new skills. So
Sorry,
friends,
guys. Sorry, my network got dropped. Okay, you can continue.
It's okay, sir. It's okay, sir. I have carried it forward.
Okay. No,
yeah. So I was asking to our participants that how you will gain these GeoAI skills. So, well, my friends, you need not to worry about this. AIGR is coming up with a new course on GeoAI. Hope my screen is visible to you, showing details of this course. So, ladies and gentlemen, it gives me great pleasure to announce the launch of our this is 16 weeks intensive online training program on GeoAI, transforming geospatial intelligence into deployable AI solutions, organized by Advances in Geographical Research, a Government of India certified ISO 9001-2025 certified research training institute. This program is designed to equip participants with cutting-edge skills in GeoAI, bridging the worlds of geospatial intelligence and artificial intelligence to create the real-world deployable solutions. With sessions scheduled on weekends, this course offers flexibility while ensuring deep hands-on learning with expert guidance. So through this program, learners will gain mastery over fundamentals of GeoAI. Other details you can find on the flyer, which we will share on our SDG Foundation Club group itself. I hope you all have joined and are member of SDG Foundation Club. So now it's time to propose my vote of thanks to all our speakers. I'm thankful to Dr. JayantaDas for giving us idea about what is GeoAI, what is its scope, and how it is important skill to learn for our budding geospatial enthusiast. I'm also thankful to Dr. Arnab Ghosh sir, who has given overview of academic curriculum included in GeoAI. And I am thankful to Ullas Ghosh sir for briefing us about opportunities, industry expectations of GeoAI. Now the session is open for question and answers. If participants are having any question, they can post it in chat box. We will be happy to answer your question. By that time, I request you all to please open your cameras so that I can click some group photos. All participants, please open your camera.
Gayatri madam, one question is there in chat box.
Okay.
Ullas, one question is there. Kindly answer it from Saptarshi Rai.
Arnab sir is answering, sir. He is there.
Actually, there is a question between traditional methods and GeoAI, which produces more accurate outputs for tasks like classification and forecasting. I think GeoAI produces the more accurate than traditional methods, Saptarshi. And for this industry, which software should I know better, ArcGIS Pro or AGI Soft? Ullas, can you answer it?
ArcGIS Pro will of course help us, but knowing open source will be better. You need to know everything actually. All the open sources, like all the open source libraries, GDAL, and like you need to go through GDAL, PyTorch, all these libraries will help us. For AI and all, you need to go with the TensorFlow. These will be our AI stuff, right? These libraries can help. But concentrating only on ArcGIS won't be able to help us. We need to focus on everything, all the AI softwares, right? And one software I can suggest, that is Orange software. You can go ahead for deep learning, right?
Okay.
So I want to put something about this question, about Saptarshi's questions. First thing, between traditional method and GUI, which produce more accurate? And I have some hand-on experience on it. I have used ArcGIS, QGIS, and Google Earth Engine, and many software. And definitely, if you use machine learning today's time, you definitely get result LULC accuracy or any machine learning accuracy up to 80%. If you find some paper 99% accuracy, that's when it's an outperform result. In case of industry, it will not allow you 99%, 100% accuracy level. Of course, GeoAI is a new era. You can use it. You should learn GeoAI, then you will get better result, obviously. No question is there. But for the industry concern, which software is required, it completely depends on your task. ArcGIS and AGI software is a different software. AGI software we generally use for the drone data processing, but ArcGIS Pro for the different purpose is a desktop GIS. we cannot ignore any desktop GIS. We need to use the desktop GIS. It may be ArcGIS Pro, it may be ArcGIS, or it may be QGIS for the visualizing purpose of some extent of work. But today, as Ullas sir and Anup sir told, we need to automate. So how we can automate our system? Definitely, we need to automate. If you want to automate your system, then you need to use the Python language. If you know the language, then you will get the chance in industry. Otherwise, only using the desktop GIS or web GIS, it is very difficult to get job. Obviously, in every field there are opportunity, but Ullas has showed us difference between our salary. Okay, if you know GIS very well, you may get 5 to 8 lakh annum per annum. If you know GeoAI, then it will transform your job. It will transform to 8 to 14 lakhs per annum. So that's the difference. Choice you. Which one you want to know? Okay, and who is better? You cannot say it is better and it is not better. It's completely depends on your purpose, your objectives. GeoAI, we need to use GeoAI, agenting AI, multiple agenting AI. All together we call it a GeoAI. It's not a different thing. Okay, this GeoAI actually is a system. Okay, you need to know everything. As Ullas has said, you need to know end-to-end product. Okay, industry searching people, skilled person who can solve the real world problem. If you have the skill, then definitely you will get the chance. And Ullas sir also told me he will show the opportunity how you will get job in industry. Ullas sir told me he'll try to show you how he got the job, how he faced the challenges. He shared with us. Then our researcher, those are in academic field, they can try their transformation from academy to industry. So I approach all the participants. You should join our upcoming course on GeoAI. It is, I think, it's a long course. I think it is a 14-week course. 14-week mean, you know, more than 3 months. Like, so you should join it. Then you can learn many things, hidden approach in our field. Okay. Thank you.
Thank you
You,
so
Gayatri
much.
Madam. Over to you.
Yeah, thank you so much, Dr. Das. So one more question was there related to certificate, obviously. So dear participants, you will receive your free e-certificate on your registered email ID. So thank you everyone for joining us today here. Let's continue mapping a sustainable future together. Have a wonderful evening ahead.